this video, you are going to explore the relationships that can be derived from a balanced equation. This is a fully balanced equation because it has equal number of atoms of each elements on the reactant and on the product side. 2 atoms of nitrogen here, 2 atoms of nitrogen here. 6 atoms of hydrogen here and 6 atoms of hydrogen here. So we can interpret this balanced equation in terms of particles, in terms of moles, and in terms of mass. So particles can be atoms, they can be molecules, they can be formula units. In this case, these are not atoms and these are not formula units. These are all molecules. So we are looking at this coefficient. When no number, no coefficient is seen in the front, that means it is 1. So here it is 1 molecule of nitrogen. That is how you're going to read for molecules. 1 molecule of nitrogen reacts with 3 molecules of hydrogen to yield 2 molecules of ammonia right here. All right. Well-balanced equation also gives us the relative number of moles of substances. So these coefficients right here in the front, 1, 3 and 2, these are also telling us the number of moles. So you could also read this equation as 1 mole of nitrogen reacts with 3 moles of hydrogen to yield 2 moles of ammonia gas right here. Alright guys, so here both of these are consumed, used. When 1 mole of nitrogen is used and 3 moles of hydrogen is used, it combines, reacts together to yield 2 moles of ammonia. Now how about interpreting this equation in terms of mass of the reactants, mass of the reactants and mass of the product? Well, even though this is a balanced equation, it's not telling anything directly about the mass. Now, can you recall that we have already learned in class how to convert moles to mass? For that, you multiply the given moles. These are the moles here, 1 mole, 3 mole, 2 mole. Multiply the given moles by the molar mass and that will give you the mass for that substance. So we'll be using molar mass as conversion factors and we'll be using periodic table for the molar mass. To find the molar mass conversion factor, let's first write the equivalence. So here is the equation. Our equation is nitrogen gas reacting with hydrogen gas to yield ammonia gas. Alright, this is our equation. This one is the reactant side, this is the product side. So these equivalents here are the true definitions. So what I have done is I have used the periodic table. I looked at the mass of nitrogen atom, which is 14.01, but it's a molecule. So what I did is 14.01 times 2, you got 28.02. So for the mass of N2. For the mass of hydrogen, it is 1.01, but however, since it is 2 here, I multiplied that by 2, and that is how you got 2.02. This one, the mass of ammonia, what I did, I looked at the molar mass of nitrogen on the periodic table, I looked at the molar mass of hydrogen, and I multiplied this mass of hydrogen times 3. Added together, I got 17.04. Once again, so this is coming from 14.01 times 2. Okay, so these are the equivalents, these are the true definitions. So 1 mole of nitrogen molecule would always weigh 28.02 grams. Now you can write it in 2 ways. You could say 1 mole of nitrogen molecule weighs 28.02 grams, or you could say 28.02 grams are present in 1 mole of nitrogen. So you are making 2 fractions from this one equivalent. Similarly, from this equivalent, you made 2 fractions. From this equivalent, you made 2 fractions. So these are all molar mass conversion factors or conversion fractions. Now, which fraction are you going to pick? The fraction that has mass at the top, the grams, the grams, the grams. Guys, this will not be given to you. You should know that. This is a part of unit analysis method. Okay, so let me come back here. We're going to work on, this side is the reactants and this side is the So what are my reactants? I have 1 mole of nitrogen. That's my reactant. I have 3 moles of hydrogen. That's my reactant. And on the product side, I have 2 moles of ammonia. That is my product. So these are my substances. This is what is given already, the moles. Now I need to change it into mass. All right. So in order to change it into mass, we are going to use the conversion factor. Here is the same equation. So this side reactants, that side products. This lesson has already been done before, but I'm still explaining this again. You start out with what is given. So what is given here is 1 mole of nitrogen. Okay. Now I'm going to here put 1 in the denominator. This 1 is unitless, so it's not going to make any difference in your answer. It just shows that we are dealing with the fractions. Times. Now I do not want moles. So when I pick the fraction, I'm going to pick this fraction here, where mass goes at the top and moles goes at the bottom. So right here, 1 mole of nitrogen weighs, nitrogen molecule weighs 28.02 grams. All right, don't forget this is a nitrogen molecule. Cancel and cancel. The same units are cancelled. Here you are going to get 28.02 grams of nitrogen molecule. Again, here, so this is one of the reactants. Now how about this reactant? 3 moles of hydrogen. So this is our given. And now I'm going to pick the fraction where I should have the moles at the bottom. So 3 moles of hydrogen we have to find. This relationship we already know from periodic table, that 1 mole of hydrogen molecule weighs 2.02 grams. So cancel, cancel, and you're going to get 6.06 grams of hydrogen. Okay. So this is your the mass of one reactant. This is the mass of another reactant. So you have converted moles to mass, moles to mass. Here on this side, the product side, you start out with given, which is 2 moles of ammonia. All right. And then use the conversion factor. We don't want the moles in our answer. What do we want? We want the grams, the mass. That's what we are working on. We are converting moles to mass. So 1 mole of ammonia is 17.04 grams. That is the mass of ammonia. Cancel these units, multiply, you're going to get 34.08 grams. Guys, don't forget to write the units, the grams of ammonia. You see here, I have written the units finally. We always write the units. Now, so here we have mass of the reactants and we have the mass of our product. Okay. So can you recall the law of conservation of mass, which states that matter is neither created nor destroyed in a chemical reaction? So if the amount of matter present before and after the reaction is same, then the total mass of substances before and after the reaction should stay the same as well. So here you're going to add these two masses. Okay, we are checking if it is following the law of conservation of mass or not. Add both these masses, this and this. When you do that, you're going to get 34.08 grams. So this is our reactants. Okay, this is the total mass of our reactants, and this side is also 34.08 grams. So you can see that mass is conserved before and after the reaction. So it is following the law of conservation of mass. Right? Okay, so now there is also an alternate way of, instead of using unit analysis, there is another way to use to verify the law of conservation of mass. You can get the same numbers. What you do, go back to your original equations. So you have here 1 mole of nitrogen molecule. So you write here 1. The mass is 28.02. grams of nitrogen, and here you have 3, so this 3 is here. Hydrogen molecule, the mass is 2.02, and here 2 moles. Mass of ammonia molecule is 17.04 grams of ammonia. Here it gives you 28.02 grams of nitrogen. Plus multiply this, you are going to get 6.02 grams of hydrogen, and here this is going to give you 34.08. Okay, now you add these masses, both these mass, when you combine, you are going to get 34.08. right? You're adding both these mass, and here this is 34.08 right here, grams and grams. Okay, but I still want you to use the unit analysis method, not this method. I just showed it to you, but use that method. I want you to pause the video. Please read these and figure out which one of these are true and which one of these statements are false. Pause the video. Well, if you said all of these are true, you are absolutely right. I want you to try this one. Interpret this equation in terms of particles, moles and mass, and also verify the law of conservation of mass. Okay guys, so balanced equation right here. So when you're reading it with as a molecule, read these coefficient as molecules. Then you're going to say 1 molecule of propane, 5 molecules of oxygen reacts to yield 3 molecules of carbon dioxide and 4 molecules of water. These are all again molecules. None of them are atoms, and none of these are formula units. They are all molecules because it's more than one atom for each side, the product side and the reactant side. When you read it for as a mole, these coefficients, you're going to say 1 mole of propane, 5 mole of oxygen, 3 moles of carbon dioxide and 4 moles of water. So what is happening here is a combustion reaction. It's a combustion of hydrocarbons. So whenever hydrocarbons burn, they yield carbon dioxide and water. Always remember to balance the equation, guys, for stoichiometric calculations. Right? So here in the next one, I have shown you how to calculate the mass without using unit analysis method. Here you go. So this one is without unit analysis method, and here I have shown you how to convert moles to mass using unit analysis method. What you did, you started out with the given moles and then you multiplied by the molar mass, and remember this molar mass is coming from the periodic table. So periodic table don't give you the mass of the whole compound, it gives you the mass of elements, and then you add the masses to get the mass of molar mass of a compound. Okay guys, I hope this video was helpful. Thank you for watching.